algorithms have been arrived at by different people in different fields because this has a lot of applications. The basic algorithm that we will talk about today is based on the ID3 algorithm, which was developed by Ross Quinlan based on the CLS algorithm. Now, the algorithm that we will talk about is a greedy algorithm. You are given to training data and you want to come up with a decision tree. Now, there could be different decision trees, a large number of decision trees that you could look for. So, instead of searching the entire space of decision trees, what we will do is use a simple greedy algorithm to induce decision tree. The algorithm is a top-down greedy algorithm. It starts by deciding which node to make a root node. Once the root node is fixed, it tries to find the children of that node, then fixes each of these nodes and try to find the children of those nodes and so on. So, this algorithm is based on top-down induction of decision trees. Now, let us look at the basic steps in the algorithm. In the first step, you try to find out the best decision attribute for the next node. So, you have got with you a set of training examples, let us say S. Now, based on S, you try to find that attribute A which is adjudged to be the best decision attribute for this node. Now, you fix A to be the decision attribute of this node. So, you make So, you make A the root of the decision tree at the current node. Now, you find out all possible values that A can take. Suppose A can take the values true and false. For each value of A, you create a new descendant. Now, these new descendant can be a leaf node or an internal node. Now, if all the training examples for which A is true, if all these training examples belong to the same class, that is all of them are positive or all of them are negative, make this a leaf node and label it by the value of the target attribute. If you see that the examples which come to this branch are a mixture of positive and negative examples, then you try to make another tree to fit here. So, you do this recursively. So, here you find the next attribute which is adjudged to be the best attribute and corresponding to the different values of the attribute, you again construct decision trees for its children. So, this is the essence of the decision tree learning algorithm. Step 1, let A be the best decision attribute for next node. Assign A as decision attribute for node. For each value of A, create a new descendant. Now, initially you had the set of training examples S. You find that subset of S for which A is true, they will come here. You find that subset of A for which A is false, they will come here. So, you sort the training examples to the appropriate leaf node according to the attribute value of the branch. If all training examples are perfectly classified, stop, otherwise iterate this algorithm over the new nodes. So, we will now describe the ID3 algorithm of Quinlan. So, this was one of the oldest algorithms devised by Quinlan. In the next class, we will look at newer versions of ID3 algorithm, C4.5, C5.0, CART, etc. So, the ID3 algorithm has inputs, the set of attributes ATTS, Q is the target attribute, and S is the set of training examples. So, you are given the set of training examples, you are given a set of non-target attributes ATS and a target attribute is Q, and the ID3 algorithm will take these inputs, construct a decision tree and return the decision tree. Now, let us look at the details of this algorithm. Now, this is the details of this algorithm. If S is empty, that is there are no examples left, return a single node with value failure or return a single node with a default class. Step 2, if S is not empty, but consists of records of the same class. So, if all the examples in S belong to the same class, you make this node a leaf node with the value of that class and label it with the value of that class. Otherwise, if ATS is empty, that is there are no more attributes left, then return a single node and label this node with the majority classification of the examples. So, S is the set of examples that you have. You find the majority class that these examples belong to, and since there are no more attributes left to make a decision node, you make a leaf there with the majority classification. Otherwise, that is if S is non-empty, but S is not homogeneous, that is S consists of both positive as well as negative examples and ATS is not empty. Then what do? Let us expand this in the next slide. Then this is what you do, you choose the best attribute out of ATS. So, ATS is the attributes that you have left, you choose the best attributes out of ATS and let that be A. And how do you choose the best attribute? You do it by processing the training set S. We will soon discuss some heuristics that are used to select the best attribute. Remember, this is a greedy algorithm. Now, once you have chosen this decision attribute A, you will try to construct a decision tree which will have A as its root. So, you will construct the tree and initially let tree be a new decision tree whose root is A. Now, for the attribute A, you find all the values Vj that A can take. Let Sj be the subset of S with A equal to Vj. So, you have all the training examples S, you find all the values that this attribute can take and you make so many branches. In each branch, you push those examples for which the attribute of A has the value of Vj. So, the training set that you have at the root, that will be partitioned into several subsets. So, the subset Sj will contain those training examples for which A equal to Vj. Now, at this branch you will make a subtree which you denote by sub t, and you get it by recursively calling ID3 with the remaining attributes ATS minus A, the target attribute Q and the subset of training examples at this node Sj. Why ATS minus A? At the current node you have used up the attribute A. So, you have come to this branch for A equal to Vj. Now, this attribute A will no longer be available for further deciding the class. So, you remove A from your attribute set and you call the decision tree algorithm recursively on the remaining examples Sj that come to this branch.